Welcome back, Algebra 1. What we're going to do now is we're going to look at ratios. And ratios compare two numbers by division. This is 2.6, ratios, rates, and conversions. The ratio of two numbers, A and B, can be written three ways. We could write A over B, we could write it A to B, or we can actually write A to B. Okay? Remembering that B cannot be 0. So for every A units of one quantity, you'll have B units of another quantity. Okay? One example is if we take in our class the number of boys to the number of girls in our class is 2 to 1, then we can say it's 2 to 1, we can say it's 2 to 1, or we can say it's 2 to 1. Okay? What this means is we have 2 times the number of girls for boys. And a ratio compares the quantities, measures in different units called a rate. So what we're going to do is let's take a look at a couple examples. Okay, problem number 1. We're shopping for t-shirts. We want to find out, well, which store offers the best deal? Okay, store A, we have $25 for 2 shirts. Well, if we simplify that, we get $12.50 for 1 shirt. For store B, we have $45 for 4 shirts. Well, if I don't want 4 shirts, I just want 1 shirt. Convert that to $11.25 for 1 shirt. And for store C, it's $30 for 3 shirts or $10 for 1 shirt. So what we know, just based on store A, B, and C, store C has the best deal because the unit rate is the lowest. If store B lowers its price to compete and says it's $42 for 4 shirts, does this solution change the actual problem? And then we want to explain. Well, if we take $42 for 4 shirts, if we simplify this or divide 4 into 42, we're going to get $10.50 for 1 shirt. Okay. Does this change anything? Well, we have $10.50 for 1 shirt now, so it's better than store A, but it is still not better than store B. So since the new price is $42 for 4 shirts or $10.50 for 1 shirt, store C still has the best deal. Problem 2. To convert from one unit to another, such as feet to inches, we multiply by conversion units to produce the desired units. This gives us a ratio of 2 equivalent factors, and the conversion factor that we multiply by is always equal to 1. So what we want to do is we want to choose and multiply by the appropriate conversion factor, and this appropriate conversion factor will allow us to divide out the common units and then simplify. So we want to take, for instance, if we have 330 minutes and we want to change that to hours, we have 330 minutes. Okay. One thing is we're going to do is when we multiply, we have to figure out, well, how many minutes are there in hours? Okay. We know that there are 60 minutes. Now, when we want to convert, we want to cancel out the minutes and just have hours. So we're going to have to put minutes on bottom. So we know that there are 60 minutes in 1 hour. By doing this, we can cancel out the minutes and we're going to be left with just hours. So this becomes 330 times 1 divided by 60. Another way we can write this, which sometimes helps, is if I go 330 minutes, draw my line, kind of like a sideways T, I guess. Okay, now I know I have 1 hour, and we have 60 minutes on the bottom. So 330 divided by 60 gives us 5.5 hours. Okay, B. If we have 15 kilograms, and we want to change this to how many grams this is. So we're going to start with 15 kilograms. Draw my sideways T. I know I want to end up with grams, so I can put grams on top. We need to think about how many grams are in kilograms. Well, we should know, or if not, we can look it up. There in 1 kilogram, there is 1,000 grams. So the conversion lets us just take 15 times 1,000 divided by 1. This is going to give us 15,000 grams. Go ahead, hit pause real quick. Try C. Welcome back. If you notice on letter C, we had 5 feet, 3 inches. We already have some inches, so if you notice what I did is I put a plus 3 on the outside of the first conversion. We got to go from how many inches there are in 5 feet, and then just add these 3 extra inches. So we go 5 feet. In 1 foot there are 12 inches, so we're going to go 5 times 12, which gives us 60. 60 plus 3 is 63 inches. Alright, let's check the got it. What is 1,250 centimeters converted to meters? We start off with centimeters. Is there a conversion rate for centimeters and meters? Hopefully you know that in 1 meter there is 100 centimeters. So we're going to go 1250 times 1, divide by 100, and we get 12.5 meters. Or using conversion rates and so forth, this is called dimensional analysis. What we can do is we can convert units between systems. So problem number 3. The CN Tower in Toronto, Canada is about 1,815 feet tall. How many meters tall is the tower? We need to use the fact that 1 meter is approximately 3.28 feet. So we start off 1,815 feet. We are going to figure out meters, and we have the conversion rate. 1 meter equals 3.28 feet. So we need to cancel feet. So 3.28 feet on the bottom, which will help us cancel feet, which is equivalent to 1 meter. So we're going to take 1,815 and divide by 3.28. This tells us that the CN Tower is about 553 meters tall. Go ahead, hit pause on the got it. Try A and B. Check back with me in a few minutes. Go. Welcome back. A building that is 1,450 feet tall. We need to figure out the meters. We're going to divide the 1,450 by 3.28. That should give us a building being about 442 meters tall. Okay. On the euros, we have a $325. When we go to for the exchange rate, we will find on a particular day that for every $1, so that'll give us the dollars that cancel out. Okay. We're going to have to multiply by 0.63 euro, and therefore for about $325 I could get about 205 euros. We can also do conversion rates. We can take a student that ran the 50-yard dash in 5.8 seconds. At what speed did the unit rate in miles per hour? Okay, and then we want to round our answer to the nearest tenth. If you notice, we got to change yards to miles and seconds to hours. Okay? So there's a couple questions. Okay? What is the problem asking for? Again, we want the speed in miles per hour. Okay? So then we look at the problem and go, well, what are we given? Yes, we're given yards per second. Okay? Third question, how many conversion factors are used in this example? In other words, how many things are we going to have to multiply, possibly, to get our final answer? And there's 2. We need to convert the seconds to hours and then convert the yards to miles. And then the next thing is, have you changed the actual amount? No, we're not actually changing the amount. We're just expressing it in different units. Okay? So how do we do this problem? We set it up. We start off with 50 yards in 5.8 seconds. You can either change seconds first, you can change yards, it's up to you. I'm going to start with the yards first. If we look up the conversion, we have yards on top, we need to put yards on bottom. Okay. There is a conversion in 1 mile. So in 1 mile, there is 1,760 yards. Okay. So by doing this, yards will cancel and we're left with miles. Sometimes it helps just to circle. If you circle the unit, it lets us know that we're through also. Okay. Now we have to get to seconds. Okay. And seconds is on bottom. That means that seconds has to go up here on top so that we can cancel the seconds. We're trying to get to hour, and right now we have miles per second. So we got to figure out, well, how many seconds are there in an hour? Well, the first conversion we can do is figure out, well, we know hours deals with minutes, So we can look at, well, there's 60 minutes in a hour, and then we can go, well, wait a minute. In a minute, there's 60 seconds. So let's start there. There are 60 seconds in 1 minute. So now if we were to multiply this out and divide, we're at miles per minute. But now, since this minutes is on bottom, I'm going to put minutes on top and hours on bottom. And we're going to be, if we do this last conversion, we'll have miles per hour. Minutes will cancel. We know that there's 60 minutes in 1 hour. So if we multiply 50 times 1 times 60 times 60 and divide that by 5.8 times 1760, we should get a student that can run at a speed of about 17.6 miles per hour. So again, we're going to multiply 50 times 1 times 60 times 60 and divide that number by 5.8 times 1760 times 1 times 1. Go ahead, hit pause one last time. Try A and B on the got it. Check back with me in a couple of minutes. Go. Welcome back. Let's check the A. An athlete that can sprint 100 feet in 3.1 seconds. At what speed was the athlete running miles per hour? So we need to change feet to miles and seconds to hours. So we start with 100 feet per over 3.1 seconds. The conversion, there is 1 mile, or in 1 mile, there's 5,280 feet. So there's our first conversion. Okay, and then our second conversion is, based on the problem above, there's 3,600 seconds in 1 hour. So we're going to multiply 100 times 1 times 3,600. And then divide that by 3.1 times 5,280. And that gives us, the athlete was running should have gotten about 22 miles per hour. And B, in problem 4, one student multiplies these 3 conversion factors to the speed. Can this method work? Why or not? The answer was yes. It works because 60 times 60 was really equal to 3,600 seconds per 1 hour, which is what we just did right here also. Congratulations. Remember, do your best, forget the rest. Bye for now.